for attending our presentation.
Everyone, and thank you for attending our presentation. My name is Cody Wood, and I am a graduate at Ontario Tech University and also one of the co authors of the paper Virtual Reality Assessment and Customization Using Physiological Measures, a Literature Analysis. Before I start, I want to acknowledge the Natural Science and Engineering Research Council of Canada and CERC for funding this project. So here is a breakdown of all the major sections of the paper that we'll be going over throughout the presentation. VR is a technology that provides the user with an immersive and interactive experience that is being used in several areas, such as education, training, healthcare, entertainment, amongst others. Currently, the most common method of assessing and enhancing the user experience in a VR simulation is to receive data from self reported questionnaires and using in VR metrics such as task completion and interactions. However, recent trends in consumer level and open electronics are allowing the use of physiological sensors to be integrated in VR experiences. So, with this literature analysis, we wanted to identify gaps in opportunities that are present with the use of physiological metrics for customization and adaptability within VR. This is because physiological data can help us understand the user's experience within the VR simulation, and physiological measures are becoming more ubiquitous due to the adoption and accessibility of the technology. A good example of this is smartwatches. To find the articles that we analyzed for this analysis, we started by narrowing the search to a time period of July 2016 2017 to July 2021, so around a 5 year window. We used a combination of keywords such as virtual reality or VR and physiological metrics or physiological assessment or physiological user experience and adaptive or customization or adaptability. So, a combination of these three sections together. The databases we used were both journals and as well as conferences. The journals included Scopus, PubMed, Web of Science, and IEEE. The conferences were IEEE VR and Chi. We separated the articles into two categories: those that used the physiological measures for assessment and monitoring the user, and the other for customizing and adapting the simulation to the user. For our results from the search, we have selected 25 manuscripts that we have separated into subcategories within the two broader categories previously mentioned. For clarity, I will present each year of the search from 2017 to 2021 with the subcategories that were present within the year. The font size of the most prevalent subcategories will be bigger in addition to being closer to the top of the list, while the least prevalent being the smallest closer to the bottom. For 2017, we found no articles for that year that did fit the criteria, showing how early years had less research in the field. In 2018, we found an article of simulator sickness and content adaptability showing the adoption of using physiological measures in both major categories. In 2019, we can see a significant increase in quantity of studies, majority of which are in the assessment and monitoring categories. However, still the upward trend within the adaptability category as well. In 2020, we can see a slight dip in the quantity of research conducted as well as a variety of categories. However, there is a more depth into the difficulty adaptability categories and adaptability category in general. Lastly, in 2021, we had the most papers. This could be because VR and physiological measuring devices are more affordable and accessible, creating an easier entrance to research and uses of physiological metrics within VR. For more details on the articles reviewed, please see the full paper. From the research, we can see that the medical field primarily used VR as a tool to diagnose and engage patients with alternative forms of musculoskeletal disorder treatments, pain management, and mental and emotional disorder therapies. Methods of doing this were to use the physiological metrics in VR simulations to evaluate emotion and physical states of the user by assessing their anxiety, attention, and mental load. Regarding training, the researchers used self reported questionnaires and biofeedback to evaluate emotions, cognition, and symptoms from the VR simulations, such as simulator sickness, to better understand the effects of virtual elements such as content, activities, and graphical quality, as well as hardware, which includes the headsets and 3D user interfaces. With respect to customization and adaptability, the research allowed a design of usable solutions that also provide an understanding of the unique needs for each user. For example, modifying the VR experience using the user's emotional state, such as anxiety, sadness, or happiness. These modifications could be visual cues, activities, difficulty, or guidance that can help the users achieve the intended outcomes of the VR intervention. We can also see an upward trend in the use of physiological metrics for customization. We can also see majority of the research being done is in the field of assessment and monitoring. For the review, we can attribute the up from the review we can attribute the upward trend of physiological metrics with VR to the availability of more consumer level VR products and non-intrusive physiological measuring devices. From the review, we can also see that the most used self-reported questionnaires included the System Usability Scale, Game Experience Questionnaire, NASA Task Load Index, and Kennedy's Simulator Sickness. As for the physiological metrics, the most used overall was the electrodermal activity and electrocardiogram. Heart rate and skin temperature were often used for assessing relaxation and emotions, while the electroencephalogram was common in papers focused on cognition and behavior. So, in conclusion, we presented a literature review of the use of physiological measures in VR, focusing on customization and assessment. We can see there is a significant amount of assessment and monitoring articles within the last 5 years, and that there is an upward trend of research being done for the use of physiological metrics for customization and adaptability in VR. We can see that customization helps alleviate the reliance of self reported questionnaires and help quantify the user's perceived experience. Additionally, by capturing physiological measures and changing parameters of the simulation within real time, we can help users succeed in the simulation and reach the desired outcomes of the VR intervention. We anticipate that the adoption rate of consumer level VR and intrusive and non intrusive physiological measuring devices will increase as they become more ubiquitous. Lastly, this literature helps researchers understand the current trends and opportunities that VR and physiological metrics present. So, thank you for listening, and I'll be taking questions now.